Hi everyone, welcome to our video on a word problem involving increasing and decreasing intervals. Alright, so just because it's a word problem usually doesn't change the strategy, and often they just flat out give you the function, and so there's not much involved with the actual word problem because we could break it down pretty easily. So let's see. So it says the number of people, P of t, in 1,000 infected t days after an epidemic begins is approximated by this function. When will the number of people infected start to decline? Okay, so this is really asking, so when does it decline is when we're looking for our interval of decrease. So that's all it really is just checking to see when or what interval they really want. So decline in this case would be decrease. So it's a quick decipher. And then now it's really just back to the same steps that we've been doing. Step one, I need the derivative. So p prime of t. Well, this is a quotient. So let's set it up as low d high minus high d low all over our low. And then we could start to plug it in. So I got p prime of t is our low function. So the 0.037t plus 1 times the derivative of the high. All right, so remember how to break down the derivative of a log function? This 500 would just be hanging out. So 500. And then the derivative of a log function, in words, I always just say put this expression, the argument of the log, in the denominator. So 0.37t plus 1. Instantly in the denominator, and then the numerator gets the derivative of this written expression that we just wrote. Well, the derivative of this would be 0.37. And then now we've got minus the high portion, so that's the 500 ln of 0.37t plus 1. So that's the high portion, and then the derivative of the low looks like it would be just 0.37 all over our 0.37t plus 1 getting squared. Okay, so that's using the quotient rule to get our derivative, but now we need to continue simplifying. All right, so now looking at it, p prime of t, let's go ahead and just get a big fraction bar. All right, so they're real nice with the numbers on here because this will cancel with this. So this is dividing this. So those it's the same thing divided by itself. So that means they become 1. And what we really have is just 500 times 0.37 for this first part of our numerator. And then minus, now the way that I'm going to write this 0.37 and the 500 will eventually multiply. So I'm just going to write them next to each other. And then the ln of the 0.37t plus 1 would be after. All over, still the 0.37t plus 1 getting squared. All right, and then now let's multiply that 500 times 0.37. All right, so I'm going to just use my computer calculator to save a little time. 500 times 0.37 is 185. Okay, so we have 185. So we have p prime of t. Let's get that big fraction again. So that's 185 minus this also is 185 times the natural log of 0.37t plus 1 over the 0.37t plus 1 getting squared. All right, so now we've got this expression. I'm just going to cloud this now. This is what's important to us. So that was our big first step, getting the derivative. Now, it's a rational function, so that means to get our critical numbers, the critical numbers is to set your numerator equal to 0 and your denominator equal to 0. All right, so our numerator set equal to 0 is 185 minus 185 natural log of 0.37t plus 1 set equal to 0. And then our denominator, 0.37t plus 1, squared is also set equal to 0. All right, and then now I want to solve each of these. Okay, so let's deal with this natural log one. Well, to solve it, I'm going to subtract the 185 on over. So we would have negative 185 natural log of 0.37t plus 1 equals negative 185. And then now I would divide. I want the natural log by itself. So we'll divide negative 185 on over. Okay, so our first goal in solving these equations is to isolate this. So this I'm treating like a big old X at this moment. So that's why I did these two steps. And then now that we have it isolated, so I have ln of 0.37t plus 1, these simplify and just give us 1. Okay, and then now, well, to get rid of a log, we just take the e of both sides. So once it's just ln on one side and a number on the other, we could just use e like this. And that way, what's going to happen on the left is the e and the natural log pretty much just cancel each other out, and we're left with just that expression, the 0.37t plus 1 equals e to the 1. E to the 1 we're just going to leave as e. And then eventually we might need to get a decimal with a calculator, but let's just leave it like this. All right, and then now I can solve for t if all I do is subtract 1. And then we'll divide. So I have 0.37t equals e minus 1. And then now let's divide by that 0.37. There we go. So we get this kind of strange t value here, which would be our critical number. So t equals e minus 1 over 0.37. Okay, so this is a critical number. Okay, so we got our critical number. Okay, and then we'll need to probably change this into a decimal in a second. But before I do that, let's go ahead and take a look at the denominator set equal to 0. Well, what's going to happen here? Let's go ahead and go through our steps. So I would try to square root both sides. Square root of 0 is 0. I don't need plus minus on 0. Okay, so it looks like this. But when I subtract 1 over, I would have this negative 1, and when I divide by the 0.37, I would get this. But this is negative time in this scenario. Okay, so it's an application. So a negative time really wouldn't make sense. Negative time, so application means it's not part of the solution. Not a solution. Okay, so what we have instead, now let's go to number 3. So I'm going to squeeze it in this little region. Our number 3 is to make our number line still. Well, the realistic time that it could start is 0. So I am just going to put that down. Say that, so it starts at time 0 is what we would realistically have for this situation, this pandemic or epidemic. Okay, so we have 0 here. And then e minus 1 divided by, let's go ahead and get that as a decimal. One more time, I'm just going to use my computer calculator. So I have e exponential, does it work on this one? There it is, e. E minus 1 is this, and then we'll divide by 0.37. There we go. Is that. So 4.64 to 2 decimals. So 4.64 to 2 decimals. So this is about 4.64. All right, and so now let's just verify what, so this I'm assuming is the time where it's going to start decreasing. But let's go ahead and take a look at it. Okay, so I want to plug in some values. All right, so we've got my f, or it's really p in this problem. So p and then p prime. And then these are t values. So I just want to plug anything in. left to right of these intervals. Let's do one at a time. So 4.64, I'm going to do t equals 0. Or not 0. I wrote 1, 0. I just thought, okay, so I can't speak right now. Okay, so it's t equals 10 is right of 4.64. That's what I want to use in this clouded expression. Okay, well, that's going to take a calculator as well. So p prime of 10 is 185 minus 185. So let's go ahead and start to plug that into a calculator. Now, this is where my computer calculator is really no good. I'm going to go to my Desmos and go to the scientific one so that I can do it here. Okay, and then let's go ahead. So I'm looking at this equation, but all I'm doing is changing the t into 10. So I have, let's do the parentheses. So parentheses 185 minus 185 natural log. Okay, so I got to go to functions. There it is, natural log of this 0.37 times 10. Okay, so 0.37 times 10, and then plus 1. As long as you type it in the way it looks, it will know to do the order of operations. And then I need to divide by parentheses 0.37 times 10 plus 1, and then it would get squared. Okay, so and we see the main thing is that we have the sign, it is negative. Okay, so I just plugged all that in. I see that it's negative. Okay, so that's what I was assuming. And so let me just mark that. So I used the calculator for this, but I'm just going to write negative. So we have our little negative symbol. Let's verify that in between 0 and 4.64, it would be positive. So I'm going to do p prime of 1. And what's good about this calculator is, well, I could just go back and just change this. Let's delete that 0 there, and let's delete that 0 there. And that's the same thing as plugging in 1 into our derivative. And we can see that it's positive. Okay, so that's what I was expecting once we found our value. So this is positive. Okay, so that means that at t equals 0, the epidemic is starting to infect people, so the rate's going up. And then on this one, they had some miracle cure that only made it last a couple days, so t days. So that means at about day 4.64, so kind of on the 5th day, is when it would start to decrease. So depending on how they want you to answer it, you might say it decreases on this interval, the 4.64 to infinity. Or they might say, at what time does it decrease? It starts to decrease at t equals 4.64. And if they said round it to the nearest day, okay, so that is in days. Days. If they said round it to the nearest days, then just say 5 days. Okay, so if it does require rounding, do that. But typically, they usually want decimals still, so it's kind of halfway through that day 4. Okay, so anyway, so the word problem, so I used the whole page on this one because our function was weird, so be careful of that. On these ones, I was able to keep it small enough to fit multiple problems on a single page because our functions weren't as bad. So if you see a nasty function, give yourself plenty of space. All right, but anyway, we answered it whatever method they want. We've got it answered now. All right, and then that's it. And one more thing, you could plug this function into the calculator, into the graphing portion, and you could start to see the curve to verify that it would go up and then it would turn down at 4.64. All right, so thank you for watching. If you have any other questions, please let me know. Otherwise, I'll see you again next time.